Let me show you where we are in Schoology, just so you know. I do need to update my links in my classroom, so I apologize for that, but I will update it soon. So just so you know, in Schoology, okay, we are now, so really we're technically still doing 1D motion. You know, we've just been talking about motion, distance, displacement, acceleration, speed, and velocity. But because there's so much stuff in this folder, I just made another folder. So we're in this 1D, 2D motion because we're eventually going to get to 2D motion, which just means 2 dimensions. Okay, so you don't have to worry about.
Will we ever get to 3D?
No 3D motion, just 1 and 2D. So yeah, no 3D motion. Although 3D would be pretty cool. All right, so we're in this folder right here, Kinematics. And I'm going to be going through this PowerPoint. Now I'm almost positive we're not going to get to these notes today, but on Thursday, we'll get to these notes and they just go with the PowerPoint. Okay, so you'll fill in these notes, not today, but Thursday with this, maybe. I'm working on it. You guys just bear with me, okay? So on Thursday, we'll do the notes. What was I gonna say? Today, we're just gonna go through the PowerPoint. So I'm gonna do the PowerPoint from my screen. So it's a lot of videos and polls. So like just asking you guys questions. So you guys feel free to unmute whenever you need to. And that's it. So we'll be going through that today. All
Is
right.
there a possible way to build up kinetic energy in your body? Well, I mean, like not in your body, but around you. Like if you're doing something like a motion, is there a way to build up kinetic energy and then like it changes the way you move, like when you release it all?
Well, technically, kinetic energy is energy of motion. So if you're moving, you have kinetic energy. You can't create or destroy energy. And so for everybody else, this is off topic, but let me just answer this question. You can't create or destroy energy. So if you're not moving, you have potential energy, and then it just changes to kinetic. So it's just kind of like doing this number. It's kind of like a ball rolling down a hill. If the ball's at the top of the hill, you have a lot of potential energy, and as it starts to roll, you lose potential, but you gain kinetic. And if I didn't answer your question, then we'll talk about it later, okay?
That's all right.
All right, so let's talk about kinematics. Don't worry about the word. I know it looks super hard and fancy, but it is not, okay? So kinematics is just about motion. Sorry, it's going a little too fast there. All right, so you don't have to read all this. I'm gonna pretty much read it to you, okay? All right, and if I'm looking over here, it's because I just wanna make sure you guys see what I see. So don't worry about that either. All right, so skydiving. Most of us know what skydiving is. If you don't, I'll tell you what it is. Basically, a person gets in a perfectly working airplane. Okay, I'm gonna look this way. Let me just show you guys. I am looking at you, so I'm right here. Can you guys see? There's 2 of me. Okay, so I'm looking at you guys right here. All right, so skydiving, you actually have this person that gets in a perfectly working plane. Okay, and for fun, we'll jump out of it. Okay, so most of us know what that is. So usually the plane's going pretty fast, pretty high off the ground, about 10,000 to 13,000 feet off of the ground. And then they usually jump out, fall for a couple of seconds or a minute or so. And then after they do what we call free falling, which means they just jumped out of the plane and they're just going through the air. And we could say floating, but they're going pretty fast. So it doesn't really look like they're floating. They're just like plummeting, like really fast, okay? And then eventually they open their parachute, which slows them down. Yes, Leo?
What was base jumping?
We haven't talked about that yet. I'm just talking about skydiving right now. So
What was
we're gonna talk about skydiving and then I'll talk about base jumping. And I'll show you a video for each. Okay? All right, so skydiving. So supposedly this is an incredibly safe activity. Not really sure if I'm sure it is. I'm just not jumping out of a plane. Now, on the other hand, my husband has jumped out of a plane 3 times. And he's still here. So it is probably pretty safe, okay? So let me show you a quick video of skydiving. Okay, let's look at this. Click. And I'm gonna have to do a new share.
Guys, we probably want. Hey, Rafi.
Hi.
Tell everybody what we're doing.
Jumping out of a plane.
Here we go.
I'm a little nervous.
I'm nervous for you. Hey, everybody, I'm Chris. We're gonna walk out here to this plane,
Yeah, my boyfriend.
and we're gonna fall for
1 minute.
1 mile.
One
We fall for
mile.
1 minute, we've gone too far. It's gonna be bad. We'll fall for 1 mile, okay? And then we're gonna hang out. Hey, Rafi, you ready?
So this is skydiving. Skydiving.
Thumbs up.
Did they just say they're gonna skydive for a mile?
It depends on how high up you are. Let me just say this in case for people who haven't skydived. Well, I don't know. Hopefully nobody, well, I shouldn't say hopefully no one has skydived. When you go skydiving, okay, unless you have taken hours, hundreds of hours of classes, you always do what they call a tandem jump, which means I'm jumping, but there is a professional strapped to my back, okay? So that's what this is. This is a tandem jump. So let's watch.
Have you been skydiving?
No. Look at that. So if you look at her face and his face at this point, you should be able to tell they are moving pretty fast. Okay, the wind is blowing past them, pushing their face backwards. So I'm going to show you this, and then I'm going to skip a little bit ahead to when they get ready to open their chute. Someone said something in chat. 1 second. Oh. All right, here we go. Oops. Now I can't see my little. Look at her face. There's the chute. Now look at the difference in once it opens. Now they're kind of slowing down. They're kind of gliding. They took off their safety glasses. All right. Let's see. Just coasting now. The parachute's open. Now they're getting closer to the ground.
Don't stand up.
There you go. So that is skydiving. Okay. That is skydiving. Now, let's talk about base jumping. All right. Now, base jumping A little bit more risque. Okay, so people are jumping off of buildings, antennas, spans, and just random parts of Earth. So often, if you're jumping off a building, it's very difficult because you got to make sure, one, I'm pretty sure most people don't want you jumping off a building. You got to avoid other buildings. You got to avoid traffic. You got to know where to land. It is pretty dangerous. If you're jumping off a antenna, they say it's kind of an easier access point or exit point because it's tall and you just kind of, there's nothing, you just jump. But you have to be careful with this. So let me show you. So you can see that a lot of times the higher you are, the easier because you have time to make corrections. Because unlike when you're in a plane and you're super, super high up, you can jump down and you have time, you know, they have time to float and then they open their parachute. But base jumpers have to like actually jump, like they kind of throw themselves off of the buildings. And then they got to make sure they make it safely to Earth. And you got to know where you're going to land. Okay. So sometimes they wear these suits. Where's my mouse here? So they wear these suits. If you can see, it looks like a webbed. So it's almost like they've created themselves like flaps, almost like wings. Okay. And then let's see, somebody just checking the chat here. I have not base jumped, nor have I sky dived. And personally, I don't think I would do either. However, let's see what you guys would do. So I'm going to do a quick poll. Let's see. I logged in from another device. Let's see if I can do it from this one then. Poll. All right. Here's the poll. Can you guys see the poll? So which one would you do? Would you do base jumping, skydiving, both, or neither? How? I'll show you guys the results in just a second. Wow. Very interesting. Look at that. All right, anybody else want to vote? If not, I'm going to close it out so you can see the results. I'll give you 5 seconds. 5, 4, 3, 2, 1. Here are the results. Look at that. Most people said they would skydive. A couple people said they would do both. And somebody said they would base jump. I am with the 3 people who said neither. I'm not jumping out of anything or off of anything. I don't have to. I like my feet right here on the ground. Okay, nice. All right, so let's stop sharing results. So let's go and look at a video. Oh, I should have showed you the video of base jumping first. Let's see if you still agree. Let me show you the video for base jumping. All right. So let's look at this. Oh, hold on. Give me a second. I forgot I'm not sharing my screen. Grammarly can. Oops, sorry. All right, let me share my screen here. All right, here's base jumping. Looks crazy. This is crazy. There's no way I do this. Ah. That's scary. All right. So all those people who said they would base jump, are you guys still gonna base jump after seeing that? I'm just curious. That is crazy to me. Like, I'm gonna jump off the top of a building. Like, why would I do that? That's crazy. All right, so let's kind of connect this to some stuff that we have been talking about before. So my question to you is, remember what velocity is and what acceleration is, okay? Do you think, let's see if I can do another poll. Let's see. That's okay. I'll just ask you guys. You guys can just unmute and tell me. Do you think the person, or you can put it in the chat, do you think the person, when they're jumping off of when they're doing the base jumping, so they're jumping off the building. So try to think back what constant velocity is. Remember, constant means not changing, okay? And then, or are they accelerating? Do you think, so basically when they're falling like this, okay, are they moving at the same speed all the way down, okay, which is constant velocity? Or do you think they are accelerating? So they're moving and then they are speeding up as they get closer to the ground. What do you guys think? I see, let's see. Ricky. Yeah, I would not do base jumping either. All right, so what do you guys think? Do you think they are accelerating, or, let me see, accelerating or constant velocity? Got a little bit of everything. All right, so I got some people said accelerating and some people said constant velocity.
Accelerating.
Accelerating?
You're going faster and faster until you stop.
Ah, okay. So some people are saying accelerating and some people are saying constant. So let's see. I have a video that will help us to decide. Let's see. All right. Let me go to the next one. Oops. All right. So let's look at this strobe of a falling ball. Oops. All right. Oh, sorry. I just realized I wasn't sharing. See, this is why I put this screen right here so I can know that I'm not sharing. So let me do a new share. Here we go. All right, so he's got a ball. He's going to drop it. Let's look at it in slow motion. So we're trying to figure out, does it fall at the same speed or does it accelerate? So here is what the final picture looked like, because that strobe light was basically showing us flashes of light. Okay, so let's do, oops. Let me share again. So this is what that picture looked like. Okay, so this is that final picture and this is what it looked like. So it said, is the ball falling at a constant velocity or is it accelerating? Any observations, my little scientist, about this picture? What do you notice about this picture?
Good shot.
The chalk, are you talking about the lines or the
I
ball?
said the chart.
Oh, the chart. Okay. Leo, what do you think?
Could you show the video again, or is it
Sure, I can show it again. Let me go back.
I almost had a seizure the first time. I'm gonna look away.
Okay, yeah. If you're gonna have a seizure, then look the other way.
I'm just playing.
Okay. So when they said this right here, 1/4 of a meter lines, what they're just basically saying is this line is drawn here every 0.25 meters. So these boxes are evenly spaced, in other words, okay? All right, this is the slow motion part. All right. And then this is the picture. Okay, so this is the picture. So I was asking, my question was, what do you notice about this picture? Any observations you are noting? You might have any observations? Anything, just anything you see. Anybody notice anything? Let's see. Oh, did someone put something in the chat? Let's see. Let me stop sharing, switch back to this. Ah, okay, so Edwin said it becomes farther apart the lower it gets. Very good observation, Edwin. I agree. So let me go back to PowerPoint here. I agree. All right, so if I'm looking at this, remember these lines are the same distance apart. Now, when I look at it, so, you know, they were continuously taking a picture of the ball falling. So in this first one, I can see the ball 1, 2, almost 3 times. It's a little bit past this second line, right? And then I can see like the ball falling here, got caught twice because the strobe light is flashing the same at the same speed. Okay, so there's 2 here. There's only 1 here, 1 here, 1 here. And if you can't see this one, there's none in this space. Okay, and that's because the ball, for those of you who said accelerating, very good. The ball is accelerating. So they drop it here. Okay, it starts out slow, and then it gets faster and faster and faster as it gets towards the bottom. Okay, now the next question says, would the velocity or acceleration, we've already established its acceleration, do you think it would be a positive or negative number? You can tell me in your chat, in the chat, whether you think it would be a positive or negative number in terms of the acceleration. Positive or negative? Okay. So far, all the answers I've gotten are the same. Let's see. Tell me in the chat. You can tell me privately or you can text to everyone. Do you think it is positive or negative, the number associated with the acceleration? Okay. Okay. All right. So let's talk about that. So let's see. Oh, got one more. Hold on. Okay. Oh, wait. What did somebody say? Ah, that is true. All right. So now let's talk about this. So here's the interesting thing. Okay. I'll tell you I'll tell you in a second what the answer is going to be. If you drop this phone, besides the fact that it's going to crack, or actually it's not even going to crack, what's going to happen to the phone if they drop it all the way down those stairs? It is definitely, for sure, going to be smashed to pieces, okay? Let's talk about this though. If we were in class right now, and hopefully no one would do this to me, but if someone was standing right next to me and they dropped their phone from here onto my head, it would probably hurt. And I'd probably be a little upset, but I'd be okay. You know, you dropped your phone on my head. Or maybe you did it accidentally, okay? Maybe you were texting and you dropped it, and it would hurt. If I was at the bottom of those stairs and someone dropped that phone on me, there's quite the possibility it could kill me, okay? And that's because that phone is getting faster and faster as it reaches the bottom. Yes, it would accelerate to the bottom, exactly, Leo. And it's gonna be going so fast, with so much force behind it, it could possibly crack my skull, okay? All right, so oops, did not mean to go there yet. All right, so here's what we need to know about this, okay? This is called free fall motion. Anytime you drop something, okay, you can drop it or you can throw it. If it's moving down and there's nothing else acting on it, we call it free fall. So when they jumped out of the airplane or they jumped from the top of the building, before they opened their parachute, they were in free fall. The only thing that's acting on them is gravity. And which way does gravity pull you? Up, down, left, or right? Somebody unmute and tell me. Which way does gravity pull you?
Down.
Down. It pulls you down, right? Which is why right now I'm not floating mid-air while I'm teaching, although that would be pretty cool, okay? So that's what we're kind of gonna be talking about is free fall motion. All right, so I have one more quick video for you, but first, another poll, okay? So this one, if we have this bowling ball here and this feather here, and I drop them from the exact same space at the exact same speed, I would like for you to tell me which one will hit the ground first. Ooh. I'm looking at the results. They were about half and half between two of the three answers. Very nice. Give me another 5 seconds to vote, and then we're gonna watch a quick video. And that'll be how we close out class. Very nice. All right, well, let's see. I'm not gonna tell you if you're right or wrong. Let's see if you are right or if you are wrong. Oops, hold on.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding.
First part is boring, I know. We'll get to the good stuff.
So that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space.
So basically, they're in this giant building, and they're gonna suck all the air out so that it mimics or copies what it feels like to be in outer space. That's basically what he's saying with all the other extra stuff he said.
Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest.
Oh. Hmm.
Now, in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, in order to see the true nature of gravity, we have to remove the air. It takes 3 hours to pump down 1,000 cubic feet of air from the chamber.
We dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
Okay, so the first time they dropped it, didn't change anything about it. It would be like if we did it right here in the classroom. We dropped a bowling ball and a feather. The bowling ball hit first. Now they have sucked all of the air out. Okay, so it's mimicking what it would be like in space, or what it would be like if you had nothing but the force of gravity.
6104 manual, 10% open. Station 1, go for drop.
PCB 30-1, pressure set point at 240 psi. We are go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Look at that.
They came down exactly the same. Wow.
Look.
Watch right there. Look at how they hit right there.
Exactly.
Macro and silent.
Exactly the same.
Feathers don't move, nothing. Look at that. That's just brilliant.
Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this: the reason the bowling ball and the feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the earth.
All right, so any thoughts on that? I thought that was pretty cool. Any thoughts? So technically, if I showed you the results from the poll, technically everyone was right, okay? So the bowling ball did hit the ground first if there was air resistance working against the feathers. But in a perfect scenario where only gravity is acting on both of them and not any other force, then they will hit at the same time. So good job. All right, so when we come back on Thursday, we're going to start learning about the number related to gravity, and you will be opening your notes that I showed you in Schoology. That's all I got today. You guys have a great day. And I will talk to you on Thursday.
Is there homework?
There is no homework.
Oh, okay.
Awesome. See you guys later. Bye. See you
Bye.
later.
Bye, Miss.
Bye. Hasta
Bye,
luego.
Miss Payton. Have a great day.
See ya. Bye, Eric.
Bye.